Okay, I'm going to show you in this video a little bit about creating graphs with controls in them. And I'm going to create a sine wave voltage with an amplitude A and a frequency F. I'm going to give the amplitude units of volts and the frequency of units of hertz. I like to label my quantities usually. I'm going to go ahead and put the borders on this little control panel. I'm going to give an amplitude of 1 and a frequency of, let's say, 10 hertz. And then I'm going to go ahead and give myself a time axis and a voltage as a function of time. And I'm going to let my time go from 0 to 0.1 to 0.2. And I'm going to select that and copy that pattern down. And then I'm going to say that the voltage is equal to the amplitude times the sine of 2 times, now watch how I make pi, I just type pi, left parenthesis, right parenthesis, 2 times pi times f times t, and t is, for the cell C6, the formula I'm entering, the time to use for that is B6, so I'm going to click in B6 and it enters a B6 formula. And then I'll complete my formula like this. Now before I copy this formula down, I'm going to go ahead and make sure that cells C2 and C3 are absolute references. So I'm going to add dollar signs to the C and the 2 and to the C and the 3. And then click the green check. Okay, now I've got a formula that points, that has 2 pi ft, that points over to cell B6 for the time, and this points to cells C2 and C3 for the amplitude and the frequency. I'm going to copy that down by double clicking, and let's see, I've got a frequency of 10 hertz, and so I have 10 cycles per second, and in 0.1 second I have exactly 1 cycle. So I'm here on the zeros. Let me just go back down to 1 hertz and see if we get something that looks a little bit better. Good. Now I'm going to go ahead and put borders on this, and I'm going to go ahead and select this region and insert a chart. And I warn you against using line plots. Please use scatter plots. I prefer straight marker scatter. And here's the plot I've got. And now we can watch as we change the frequency to higher values. Well, obviously we're undersampling here. Maybe we can go to lower values. 0.8, 0.7. We can decrease the amplitude if we want, and the plot responds. One thing that we might like to do is to go ahead and keep the axes of the plot from changing every time. And to do that, I'm going to go ahead and click on the axis, and then I'm going to right click it. So I've selected the axis. I'm going to go to format the axis, and I'm going to tell it to not use automatic min and maximum. I'm going to set the minimum at -1, and I'm going to set the maximum at +1. And now they're not being set automatically. I've overridden them, and you can see what happens here. Now when I change the amplitude to 0.1, it really does get small. If I change the amplitude back to 1, so the vertical axis is staying fixed. Other things you can do here include left clicking on the data and then right clicking, and you can do a variety of things here. You can, well, some of the choices have gone off the page here, but this is then a nice demo of using absolute referencing for a control panel on a graph. Notice that when I click on one of these cells down here, I can also click in the formula bar, and I can see indeed that my formula in this cell is pointing to the time, and it's pointing to amplitude and frequency that are fixed up here. And you can see everything's color coded. B13 is purple, C2 is blue, and C3, the frequency, is green here. So there's a nice, hopefully useful demo for you on creating sort of a control panel for a plot.